one. We're going to go to that. Do I have multiple tabs, multiple monitors open or something? No, okay. I'm going to hack my app and that's going to crash it. So, okay, who's Biscuits? All right, well done. You will collect your prize afterwards. Who is Joseph? Joseph works at Datadog. He doesn't count. Depunker. You will also get a Yeti mug. Thank you for participating. I needed a bit of noise. And we can actually see on this dashboard, I've put out basically a bunch of widgets. The idea being that, okay, we can see memory is high. We're going to be able to dive into this sort of information and the spikes across. We're also grabbing information from disparate parts. So we're also grabbing information from the logs. So we've got a log streams coming through. And basically, whenever you're logging, whenever you selected EC2 or Lambda or added in other, COBOL on Lambda is actually the third highest. That's impressive. Number of requests. In the other fields, basically, we're logging that information. So the idea is, with this dashboard, you can easily plot out whatever you need to do. So whether it is utilizing metrics that are pulled from the Datadog agent that's running in the environment, or whether it's the Datadog Lambda layer that is running obviously on your Lambda functions, or pulling in metrics from CloudWatch, or whatever else, what other integrations we have running. The idea is it's all tags based. So if I want to scope into, for example, a particular AWS environment, I have all my AWS tags already inherited here. So whether we're looking at an infrastructure metric, an app metric, a Postgres metric, because I'm actually running a Postgres database in the back end, we can just start to type this sort of stuff in and average this every host. The idea is we want you to be able to easily access information. We don't want you to have to learn some sort of arbitrary schema language. Now, if we go and look at some of the actual traces, now I don't know what we're actually going to see here, so this is kind of going to be interesting here. That's probably going out to, yes, that's going out to API Gateway. I might open one that, we've got some quite long duration requests coming through. Now, I'm going to jump into one of these traces. So this is a trace in Datadog where we are going through a Lambda function, and we've collected those X-ray traces as well as the Datadog traces. We can see it's making a request out to, for example, an Express service, so JavaScript. It's going out to another Express service, going out to another Express service, and can you tell I'm a JavaScript developer? And going out to a Postgres database as well. Now we can follow it all the way, even if it's in disparate parts. It could be on-prem, if you've got hybrid cloud as well. It doesn't matter where it is. All this information will be correlated, including, for example, your infrastructure metrics. So in infrastructure in a host, that's fairly straightforward. You know, what is CPU usage doing? What is memory? That kind of, you know, basic fundamental stuff. In a serverless environment, we are also inheriting and correlating that through to, for example, total concurrent executions in Lambda. So you're able to grasp all the infrastructure metrics that you're likely to need to quickly triangulate where the issues are arising in this instance. And you have all these tags that are applied to it as well. So you can see if it's in a particular AZ, you can see if it's a particular region. We also have our application logs. And again, this goes across the stack. So whether it's a Java application that pulls out to the JavaScript application that goes to a Python service, it doesn't really matter. The Datadog tracer that's running in your backend is going to be injecting this trace ID into your logs. And that's how we are able to tie this all together. So whether it's a Lambda function where we see the request logs coming through, whether it's from Express and whatever else, the idea being that you have all the information in one place. So you'll hear single pane of glass regularly in any marketing material that you come across in the observability space. This is how we do single pane of glass in Datadog. We don't want you jumping into a different part of the product, searching up a timestamp, searching up, you know, tags and all that kind of stuff where we can avoid it. We correlate it for you. So the idea being that you just jump into that particular request and you have that information straight away. Now, this also applies in the context of breaking down the silos between the different teams that I mentioned earlier on. Your networking team, your app infra teams, your app teams, they can jump into this and they have all the information that they need. They don't need to wake up the app SME for that particular team because they can see the trace. If an error was thrown, I think we've got a stack trace being thrown here, we see that highlighted as the red boxes for that particular span. We can see the stack trace and understand, okay, where are we encountering this particular issue in the environment? So again, information sharing across teams. Now, there's also the correlation piece from the front end itself. So real user monitoring in Datadog, basically in the context of a web application, it's a JavaScript SDK. In the context of a mobile application, there's iOS, Android, native SDKs, React Native, Flutter. I think there's one or two others, I can't remember them. But you're pretty well covered, and the benefit of doing this is if we actually browse back to one of these traces, we see this browser request. We've traced it from that particular user's session. So if we actually jump into the information, we can see that full session in real user monitoring in Datadog, where they encountered that error, what sequence of steps. If you have a support team, T1, T2 support engineers, going through and getting requests, support tickets from your customers using your services saying, hey, I tried to make this particular purchase, I was unable to, well, you can just go ahead and search up that particular username. And with that information, now you have, oh, okay, they browsed this page, they clicked on this button. You can even see a visual play-by-play as they're going through, measure core web vitals from the user experience perspective as they're going through the application itself. So effectively what we're doing here is logging this information as we're making DOM object manipulations and collating this information obviously in the Datadog platform. Now, if they browse one of these pages, any of the XHR and fetch requests, well, we can trace that through to the backend because we generate that trace ID at the user browser, at the user's browser. So we can see, okay, they complained about poor loading times. Well, we can see how long the browser took to receive the response. We can see how long our backend actually took to respond as well. And then from there, okay, they're browsing it from Australia. Maybe I'm serving this content out of a different region. Let's scope into where this Lambda function was located. Maybe it's in the US. And that would explain some of the latency that we're encountering. So trying to tie these two different pieces, or multiple pieces together into one functional story. Now, with respect to observability, the 3 pillars and front-end monitoring, well covered, that's sort of table stakes for Datadog. Now, we've kind of realized, well, okay, we already have your logs. Let's actually start maybe using this data source as more of a security lens. So, okay, let's actually develop a Cloud SIEM product. So yes, we have a Cloud SIEM product. If we go to security over here, there's Cloud SIEM. So we can monitor and ingest our guard duty logs, our CloudTrail logs, whatever else logs you want. And it's all tags based in the logs as well. In addition to that, evaluate your security posture management. Is an S3 bucket completely publicly exposed because an engineer made a bucket to test and they forgot to delete it? Let's poll the API regularly and be notified of this. And we can even automate some of this information as well. So for example, with application security monitoring, we actually do that through the Datadog tracer. I think it's this trace over here, where we can see a security tab pop up. And basically, somebody has tried to inject a bit of SQL, and they weren't successful in this attempt, but nevertheless, we probably want to start to move towards coordinating the security focus in the Datadog platform. Yes, we can log into AWS and block it in the WAF. Why not automate that? So we're moving towards more automation. So if we go to service management, we actually have a workflows product where you can actually build up a workflow based off of triggering an event like an alert in Datadog or a security signal in Datadog. Let's actually build one of these up. I think I actually got one already. And update our WAF based off of whenever this workflow is mentioned. And let's go into AWS. Let's go into AWS WAF 2. Let's add that IP to the set. And we will say whatever the attribute is for the IP address that we want to block there. So we can start automating this and removing some of the hurdles or the management side of it around maintaining our security of our application itself. Or in the case of an S3 bucket being exposed, let's just automatically block, send a request out to the AWS API and block off that security group. Now, I think there's, I guess, one final layer which I think is worth covering. Now, if I can actually change tabs successfully this time, let's just minimize that and go to this one. So this is the main Datadog demo environment. This is probably what I should have been using for today. But nevertheless, the idea being that as we have many microservices, and as we're collating information from the front end, from the back end, from different services, our microservices stack can get very complicated. We dynamically put this together. It's nothing too groundbreaking. But if we go ahead and view the service overview, one of the tags that we strongly recommend utilizing within the Datadog environment is the version tag. If you're doing regular releases through a CI/CD tool, set the environment tag, set the version tag in your AWS environment as as part of your CI/CD pipeline. Now what that allows you to do is easily differentiate, for example, across different versions. So any of these metrics that we're pulling in from the application side are easily viewed, in a color-coded fashion to see that, oh, okay, we have an increase in latency in this particular version, and if we go ahead and scope into deployments, well, we can go ahead and see the different percentile latency figures, see if new error types were being caught or exceptions being caught. Jump into the errors tab over here. Okay, great. We have no new exceptions being caught, but we do have an exception no longer appearing. So that's good progress, right? But sometimes when it comes to alerting, we can alert based off of error rates, but we don't always necessarily know what those errors should look like. So while we can apply, retrospective alerting procedures, we can also utilize machine learning within Datadog that will be evaluating, for example, infrastructure metrics, log patterns, trace patterns, and this kind of information, and applying that to build up effectively storylines. So if I open one of these, I think I should have done this in the prod environment, we can start to see that, okay, with this new version release, for example, we might see increased errors and latency. And that has degraded these particular services downstream. So we can start to tie these disparate pieces. If I had real user monitoring enabled, I can also see, for example, the users that are impacted. And that allows you to tie through, and if you're, for example, an e-commerce store, reach out to those customers saying, hey, I noticed you tried to browse and purchase this particular product. Here's a 5% discount. Can you please retry? We fixed the issue. So tying the information in your observability stack into digestible stories that you can easily validate, because we will provide the context around why we believe this to be anomalous. We won't just say, hey, this is anomalous, off you go. We do provide the context around, okay, it's this particular version that was affected, and these particular users were also impacted as a result of it. Now, I think that's pretty much, how are we doing for time? I don't know what time I started. I think we're all good. Yep. I think I've got a minute or two left. I'm happy to take any questions. I'm also happy to take questions afterwards as well. Yeah, thank you for participating. Oh, I did actually say there was going to be one more. So there was going to be a surprise sort of extra third Yeti mug. In some of the other AWS user groups, we actually have had people attempt to hack my poorly made app, and it has actually worked. That was going to be the surprise, but unfortunately I had to take down the application myself. So we'll give it to the third number of requests. So let's just go back to the past 30 minutes. And Gokul. Who's Gokul? Yep, you'll get a Yeti mug as well. All right. Any questions?
Please raise your hand if you have questions, and I'll come with the microphone.
Yeah, go ahead,
Yep.
Gokul.
You said you'll be updating IP address, for example, to backlist set of IP address. So how does it impact with some of the CloudFormation? Say, if I have an infrastructure built using CloudFormation and whitelisting all the IP address and based on CFN, does this create a drift? How does it impact that?
So in this particular case, what would be triggering the alert would be something that would look like SQL injection in this attack, or it could be XSS or something like that. Now, based off of whoever made that request, that information is logged. We extract that IP attribute out of that log and block it based off of that. So if it's a dynamically generated IP address, that's fine. It will be populated as a result of that. You can also add conditional logic around the workflows product. So if this, then evaluate particular, for example, a call out to an API. The API could be AWS's API itself, or it could be your own sort of, if you expose your whitelisted ranges, make sure that it's not part of that range. If it's not part of that range, then execute this particular logic function of blocking in the WAF. Does that answer your question?
Yeah.
Okay.
Thank you.
Anyone else? Yeah.
I'm a little bit curious with Datadog. You've run your app. How do we tell from the landscape of the single pane of glass how well your app did today? And what sort of problems does it highlight?
That would be probably done through the service overview page. So I have gone to the wrong tab again. But effectively, the service overview page is out of the box. It's going to provide you the golden signals around the sort of app deck scores, requests, latencies, that kind of data. And from that as well, if you want to be alerted of anomalous behavior, or if you want to understand at the endpoint level how are those metrics performing, this is all provided out of the box, basically. And if you need to understand, for example, why one of those endpoints is increasing in latency, well, you can go ahead and scope into all the requests from that particular endpoint, and from there dive into, okay, what services are actually operating downstream. That could be impacting the overall request duration. So that's actually one of the widgets that is displayed here by downstream service. So we can see this web store service, for example. It's making requests, it sometimes spikes. So starting the investigation process through that as well. Alongside, the Watchdog product that I highlighted earlier on that will basically alert you of anomalies. So based off of baseline behavior, or seasonal ingestion of whatever endpoint metric it is that is being ingested, do we see a marked decline in the app health? And I mean, the idea with Watchdog is effectively to help you monitor the unknown unknowns. We can set up all sorts of alerts in Datadog. It's nice and simple with a tags-based mechanism, but there's always going to be those things that slip by, or you start utilizing some new resource that you didn't necessarily fully understand, and let's have some machine learning applied to some of these services.
Cool. Nobody else? Then Nathan, thank you very much for an insightful talk.
Worries.
He's the person who's always responsible for the food and drinks. So that must make him your favorite organizer. So, welcome, Matt.
Sweet. Awesome. Okay, so AI can have my job. Starting off with who I am. For those of you who don't know. Principal consultant, CMD, been there about 5 months now. Spoken here a bunch, on the organising committee, etc., etc. Was a maker, beer drinker, tinkerer, like to build things, play with things, do all of that. I am now a dad and don't do all of that. Community builder, former ambassador. If I've been at CMD for 5 months, I guess that means I'll be reapplying in about 30 days for the ambassador thing. And currently hold all the AWS certifications. So if you want to have a conversation about that, more than happy to. And I can confirm the golden jacket is a thing. So, was meaning to bring it, apologies, didn't. the thing is, I'm not actually going to be presenting on my own tonight. I'm actually going to be presenting with this gentleman. Why is that coming out here? Because Matt needs to change his audio source, apparently. Yeah, this is what happens when you don't test. That's okay. Test, yeah, exactly. It's in here somewhere. Anybody know how to use a Mac? There we go. Chris Run. There we go. That should work. Let's try again, shall we? Nope. Still no. 1 second. We can always try the when in doubt, close it and reopen it, because audio drivers do really weird things and sometimes don't like being changed mid-flight. If not, I'm sure I can do the age-old hold the microphone up to the speaker thing. Where are we? User group, aren't we? Hey, I can have my job. There we go. It's only 3.7 gig. That's not a very big keynote presentation now, is it? Nope. Yeah, that's all right. We can. Where are the microphones on this thing?
Hello, my name's Klaus the Cloud Cat, and I'm here to help Matt present to you the content creation platform that he has built on top of Amazon Web Services.
So he's currently talking to you, trying to introduce himself. That's okay. So this gentleman is Klaus. Klaus is a automatically generated video from an AWS step function and serverless application. So it's not just a video that I created in Premiere and stuck in the thing. That would not be as impressive as this is. The reason I'm sort of having this conversation is, as I mentioned earlier, I'm a dad now, but I'm also a community builder, want to be an ambassador again, and for those of you who aren't aware, there are all of these conditions around being a community builder, around producing content, videos, blog posts, etc., so that, you can teach people how to use the wonders of AWS. Right? So I needed to produce a lot of content. However, it takes time, and I don't have any time. Time is a constraint for me now. And if we think about Eliyahu and DevOps and everything that teaches us, it teaches us the constraint should be exploited or elevated. So I want to automate the process of creating content. The really nice thing about being a community builder and wanting to start a project to automate the creation of content is that the process of automating the generation of content is content. So it's kind of a self-fulfilling thing here where even if I don't succeed, I've technically still done what the community builder and ambassador programs need me to do, which is kind of a nice little thing. So it's a win-win for me. So what I've done, or what I've tried to do, is create a serverless application that will turn that text, which is literally nothing more than a text file, into a animated video. So all you do is you create a text file and you turn around and you say, this is the type of scene I would want. So I want alpha, which is, for those of you who don't know video, it's got an alpha channel. So there's a transparent background so that I could put it in the slide. Nice and simple. The character's name is Klaus. There are a set of characters that I can define within the application. And then I just give it the text file, the text that I want him to read out to the viewer. Nice, simple, easy. It goes away and then builds the application. Now, the problem here is Klaus.
Well, it's a serverless application that allows a user to provide a piece of text, say a script for a YouTube video, and submit that in an API gateway. The application will then automatically generate the video, including all the required animations, and upload the finished product.
Yep, we can just barely hear it. Okay. Audio. Play. Here we go. If I actually select the right select the HDMI in the right spot as opposed to just telling it to do the alert sounds through, that might work. Let's give that a shot again, shall we? Well, I'm not getting audio at this end. Nothing coming through HDMI. Testing in production, also not so good. What was that? Alert volume down. I don't get output volume. I don't get an audio when I select the Crestion as an output device. My output box is grayed out. It does not like me. Oh, that's sad. Oh. What do we got? Oh, yeah, we got plenty of time. Yeah. What's the worst that can happen? No. Nope. Don't have a plan B, unfortunately. This is what happens when you test in production, but that's okay. Play it on the speaker and we'll just hold the microphone very close. We can. Okay, cool. Well, we can give that a shot again. Bum-bum-ba-da. Do-do-do-do. Ba-ba-ba-da-ba-da. Searching for Bluetooth. Speaker.
That might work. Alright.
Connected. Sound. We go Bluetooth. We go like this. Yay! We have the technology. Cool. Easy done. Okay. So, all right, let's try this again, shall we? So, all right, now it's over to Klaus to explain what's going on.
Well, it's a serverless application that allows a user to provide a piece of text, say a script for a YouTube video, and submit that in an API gateway. The application will then automatically generate the video, including all the required animations, and upload the finished product to YouTube. In a future version of the platform, you'll soon be able to provide nothing more than a subject prompt. But no guesses on how that's going to be done. But for now, let's just dive into what makes up the platform and how it works. It's actually not all that complicated once you break it down into its individual components. As you can see to the left of me, the platform is made up of nothing more than an API gateway. A couple of lambda functions, some S3 buckets to put the data in, and a step function which contains the magic sauce. We'll dive into the magic sauce part a little bit later, but for the moment, let's start at a high level and work our way down. The solution can be broken down into two main parts. The first part is what's called the submission component, which contains the API gateway for users to submit jobs and get updates on their status. A lambda function that accepts an incoming payload and one, saves the incoming text file to an S3 bucket for consumption by later processes, and two, writes a record of the job to a DynamoDB Then we have the step function, which takes the inputs and creates our finished product. It uses a separate S3 bucket to store all the generated artifacts it needs along the way. It then writes the video to the output S3 bucket where it can be fetched by the user. Or the upload lambda function can upload the video to YouTube for us automatically. And as far as the bulk of the application is concerned, that's it. Not a lot to look at, and at a high level, not particularly interesting. But what about that step function? What's inside that little nugget? Well, here it is in all its fine glory. An unimpressive looking step function, and one that desperately needs error handling and logic checks added to it. But one that is fine for the moment. Famous last words, I know. Starting at the beginning, the step function takes the incoming text file that's been provided by the user and rips out a whole heap of stuff. The reason we need to massage the text first is that we're going to want to generate speech of our text. But the text file also needs to contain other pieces of information, such as when we want images on the screen, what background we want, and so on. So all the information needs to be stripped out before it's passed to the next step, which is actually 2 steps. We pass the same text file to Amazon Poly twice. Once to get back a wave recording of a completed speech, and one to generate the associated metadata, which contain details like when each word or phone name was said, which we'll need later when it comes time to lip sync my movements to the text. In the interest of full disclosure here, the current version of the platform boasts a little bit uses a third-party text-to-speech engine, but we didn't get time to update the images with the new steps. But the process is essentially the same. Once the WAV file and metadata are returned, we can calculate all the audio and video parameters. The metadata that was returned, as well as having details on when each word was said, also contains information on when each image should be discovered in relationship to the length of the audio. So we need to align all the pieces together so that we know what needs to go where in the video. Once we've got that, we can create the master of all CSV files. We generate a row in the CSV file for each frame of the entire video, 30 frames a second for every second footage, based on the length of the audio recording. This serves as a list of frames that need to be drawn before they can stick back together again, which leads us to the draw frame component. This is a distributed map component that takes the CSV file of fans out the records to an army of lambda functions. Each lambda function gets 10 frames to draw, and using iGame, draws that frame and saves the output to an S3 bucket. For a modest video like this one, you can have hundreds or thousands of lambda functions running in parallel. Distributed map handles all the retry and backlog logic, making it a really easy way to scale out the process. Thank you, we're in Event 2022. The next part is the bottleneck of the solution, and one I've been needing to fix for a while. For a 10-minute video, we now have 18,000 PNG files sitting in an S3 bucket that need to be stitched together to create a video and an audio track that needs to be overlaid with it. This is super easy for FMPEG, and FMPEG is easy enough to run in a lambda function, but it doesn't scale very well. It's one of those, it works as long as the video is less than about 15 minutes in length, and the recursive distributed map of FMPEG jobs will fix this. Matt just hasn't gotten around to it yet. But either way, we get to the final state of the step function with a finished video ready for consumption by our adored fans. It's not the coolest way to create videos, but it's quick, easy, and it's been a super fun project to build. And with that, I'll hand it back over to Matt to close out the presentation.
Okay, so as was explained, this is actually the newer version of the application. Apologies, that's an export from, the PNG that you get from step function export it's good, but it makes it hard to present on a screen. As Klaus mentioned, we've made a few little tweaks as we've sort of gone along. Poly's great, and this is sort of something that people should take away for a lot of machine learning tasks, shall we say. AWS makes it really, really easy to do some really, really cool things, but it's not always a super great fit when you start getting off the well-worn path. Poly worked really well, and it's great that it gives you the metadata with the phonemes and breaks down, and you get a nice JSON file of exactly when everything is said, what word, what sentence, what phoneme, all of that sort of stuff makes lip syncing super easy. The problem was, long term, I actually want it to use my voice. And let's just say that poly pricing for custom voices is one of those, please speak to your enterprise sales manager and he'll give you a quote for an absurdly large number sort of thing. So probably a little out of the realm of, like, if I'm going to spend that kind of money, I may as well just pay somebody to do this for me. There are a lot of AI platforms online nowadays that offer what's called voice cloning. Some are good, some are less good. So we're actually using play.ht at the moment. Relatively decent platform, relatively affordable. But to get the voice cloning stuff, I think it's going to cost us about $200 a year, which is a little pricey. But, yeah, so we've got that working. The rest of it works pretty much the same as was said in the video. It uses Pygame to generate a whole heap of images and then spits them out into an S3 bucket, and FFmpeg stitches it all back together. There's actually really not that much to it. The purpose of this presentation isn't actually to show off the cool, nifty thing. Like, you know, it's cool, it's nifty. There's some reference code on my GitHub that I'll share a link with if people want to go and have a look. It's more about, this was originally a presentation I gave at the Programmable conference last month, just around some tips and tricks that I sort of learnt along the way of dealing with and sort of trying to build all of this out. The first one is naming conventions. Back in the video with Klaus, you will have noticed that some of the names for the functions are not great. Not a huge problem when you're building the application out, but when you start trolling through errors and logs, naming becomes a really important thing, because you're pulling, particularly in the serverless land, you're firing a lot of Lambda functions, a lot of step functions, and you're trying to track things through. Having logical naming conventions makes things really easy, and having, you know, voice marks and voice markup, and yeah, you could probably do a little bit better than that. So think about this from the outset. Piece of paper, write it out, have a think, spend 10 minutes. It'll save you a lot of pain later on. Workflow Studio. I built this platform using Visual Studio Code and text because I'm a professional cloud engineer and I don't use no stinking GUI because I'm hardcore. And man, was that stupid. Workflow Studio. Drag and drop. Drag what you want, tell it where to go. It will give you, if you have a look on the right-hand side there, it then gives you the actual code that you can copy and paste into your GitHub repo. Do not make this hard on yourself. Use the GUI, smash it out. Yeah, you're going to need to go back through and, you know, parameterize and, you know, put some variables and whatnot in, but man, this makes life so much simpler. So don't forget that the GUI is there and, you know, take advantage of it. The next one is serverless land. If anybody is doing serverless and hasn't seen serverless land, I highly advise you go and take a look at it. It has hundreds and hundreds of patterns and references and examples of all different use cases and scenarios that you're going to come across in the serverless space. It's got full step function workflows. It's got Lambda functions, API layouts, the works. Go in here and, you know, you want to fire an API gateway and have it fire an event bridge function that then's going to go and call something else. There's a reference for it on here. Go copy paste. It's just a whole bunch of, you know, GitHub projects and that. It will save you a lot of time. One piece at a time. And this is kind of a do it with a yes with a no, you know, no with a yes kind of thing. The nice thing about building step functions, serverless, you know, Lambda functions, all that sort of stuff, it can be a very piecemeal process. It gives you the ability to break your problem down into individual components and deal with them piece by piece, all right? So when I sort of mapped this out, and it's like, well, okay, I want to take in a text file, all right? And I'm going to need to massage that before I send it to Polly. Well, that's the first step. And you can sort of break it down into its, individual components, deal with them one at a time. You can validate what you're getting in. You can validate what the function's then sending out. You confirm that is working before you move on to the next piece. It sort of gives you a very clean way of sort of working methodically through your problem. Observability from the outset. Lambda functions, or functions in general, typically not particularly hard. I want to pull the text file from the S3 bucket, and then I want to basically do a big for loop on the text file and pull out all of the parameters. Not particularly difficult. Easy, right? Fine. When you start then building Lambda functions that run 18,000 times simultaneously, and you then get an outputted video which seems to be missing a half a dozen frames, and you've got to go back through the 18,000 executions of that function to try and find the 6 that didn't work and why they didn't work, is painful if you don't already have the tools set up to do that. Make sure you're outputting your logs. This is where the naming convention thing comes in, because again, if you don't have logical naming conventions to your log groups and your logs, this is going to be difficult. And throw yourself together a dashboard. Doesn't need to be, anything complicated. But if you go and look in CloudWatch, there are a lot of very useful metrics there that are there by default that you can just turn on, throw on a dashboard, and it will give you a lot of visibility and understanding into your application. Well worth the 3 minutes it's going to take you to do it. Run things in parallel. The great thing about serverless is that you don't really need to worry too much about, reaching capacity. If you build a platform that uses up all of the available Lambda capacity in Sydney, that's a really interesting use case, and I'd like to talk to you because I'm sure it'd be fascinating, because that's a lot of compute. The thing is, concurrency limits and all of that notwithstanding, run things in parallel, right? Like, I'm making 2 calls to Polly, do them at the same time. That's AWS's problem to manage the capacity on that one. Distributed map. I won't get too much into the whole distributed map thing. Distributed map now supports JSON, so I can actually go back and get rid of the CSV file thing. That's a little annoying. But distributed map, take a look at it if you haven't. reInvent 2022 did a lot for step functions. Basically, you give it a CSV file. Distributed map will then, loop through the CSV file for you and fire off all the relevant Lambda functions, pass each one the row as an object. You can simply just tell it, I want 10 rows per execution of the function, and distributed map goes and takes care of everything else for you. You don't need to worry about, checking SQS queues and, retries and, reporting and all that sort of stuff. All done. Simple. Drop it in. Simple. Service quotas and limits. I mentioned scale out, run things in parallel. Regardless of whether you're running things in parallel or you're running things sequentially, keep in mind the service limits, particularly for a lot of the managed services that AWS offers. The one that really caught us out, Polly, 200,000 character limit. They really do not like upping that number unless you have a really good use case. It took me 3 attempts with the service team to get that number upped. And even then, they would only up it to 300,000. Now, 300,000 characters is a lot of characters, I will admit. But, if you start playing this out to like a 30-minute video, you could hit limits relatively quickly. So just be mindful, the documentation for service limits is getting better. It's pretty good. There aren't too many things that aren't documented. But yeah, that's the sort of thing. It's also the same reason why the API gateway calls a Lambda function and doesn't call a step function directly, just because there's some handling there with synchronous tasks and all of that I didn't want to have to deal with. The only other one sort of on this list of tips and tricks, Security. This is going to get me in trouble with a couple of people. If you look up reference architecture for security on API Gateway, you will get a very cool diagram with Cognito and single-use tokens and all of this. Yeah, great, cool, don't care. If I needed to go through that much effort to get an API Gateway with some authentication up and running, this project would never have been built. It is not, strictly speaking, the best way to do things. API keys, usage plan, done. Right. This is a small application just used by me. You know what? If somebody works out how to smash it and get an extra couple of uses, it's going to cost me a couple of bucks. Fine, I'm willing to wear that. Security to the right level for the use case. You don't need to over-engineer. You don't need to engineer it to the nth degree, just because it's best practice. Where to go from here? Wanted to sort of end on a couple of, future thinking kind of things. AI can have my job. Cool, great. Automated the process of creating videos. It alluded to, being able to go from giving it a text file to just say, hey, produce me a 10-minute video on DynamoDB. ChatGPT, obvious, duh kind of thing. That'd be relatively simple. Last week, AWS announced the whole generative AI platform thing. I'm sure everybody's LinkedIn and that was spammed with 1,001 people going, look at us, how cool is this? Any AWS people, I'd love to get on the beta of that one. Like, I've got a perfect use case for it right here. At the moment, ChatGPT is getting my money. Happy to give it to you instead. I know it's only with their internal teams. That's why I'm making the comment. I'm giving them a little bit of a prod to, I don't care. I want it. I don't want it. I know we all want it, but I'm the one with the microphone. As I mentioned before, ML of my own voice, because if you play this out, a video without the video component is a podcast. If it's only audio and it sounds like me, then I just don't tell them that it was created automatically, and voila, content without the automatically created content bit. Voila. Like, not trying to game the system, but yeah, totally gaming the system. Yeah, kind of, a little bit. Add custom pronunciation. I deliberately left in, it does not always catch things. DynamoDB, really doesn't like AWS, needs to be Amazon Web Services. There are ways for us to build custom pronunciation dictionaries, manage all of that, get things a little bit better. Better animation of the character. Yeah, his lips move, but nothing else does. There's a bunch of different things here, and then a web interface so that we can sort of flesh this out. The last bit I sort of wanted to flesh out was, this is where it gets really interesting, and this is sort of where I'm going to, leave it, is there are RSS feeds on things like what's new in AWS. You can scrape those RSS feeds with a Lambda function and write it to a DynamoDB table that you could then pump to ChatGPT to have it generate the text file, to have it automatically generate the video. And now all of a sudden, it's automatically generating content from beginning to end without me having to do anything. And what we end up with So that's gonna be on the YouTube channel this week and every week going forwards. Now, this is a simple one for the community builders and ambassadors in the room. I will leave you with this. If you have a look on my GitHub account, you will also notice a Lambda function that will automatically submit your content to the community builder and ambassador portals for you. So I can actually get the whole thing from beginning to end done without me having to do anything, and I have now completely automated the process of being an AWS community builder. And that's me. For those of you who are interested, few reference pieces of reference material, some workshops. AWS has really gotten into the workshop thing the last sort of 6-9 months. Really good stuff on step functions. Carrie KH YouTube channel, machine learning, a whole bunch of bits and pieces. That's where I actually got the original idea to go down this rabbit warren of a thing. And just a few more best practices. Serverless application lens, got some really good tips and tricks there. And as I mentioned before, serverless lens. And with that, I am done. Oops.
Does anyone have any questions?
No questions? Oh, there.
First, why? Second, congratulations on completely breaking the process. Third, the custom voices that play.ht does, how do they work, and how long do the samples that you give them need to be, and do they require you to record specific samples?
So first answer, why? Because I can, and I like breaking things. Which is also, the second bit is, congratulations on breaking that. Yeah, somebody was going to do this eventually. It may as well have, been now. As for the third one, play HT. Thus far, I've pumped in my recordings from each of the episodes of season 2 of the User Group podcast. Small call out. User Group has a podcast. It's on the website. Go have a look at it. Which is probably about 4 or 5 hours of content thus far. It has done an, I would say, bearable job thus far. You can give it whatever you want. They say they can train their model on as little as 3 minutes of content.
I don't believe that.
Look, I'm sure they will build a model with 3 minutes of content. I don't think it's going to be any good. I think most people will agree I have a somewhat odd speaking pattern, and the model represents that pretty well. It's either way too quiet and passive or completely over the top and excited beyond belief. So some would say that does actually, mirror me pretty well. But it's sort of, not there yet. It's the age-old thing, garbage in, garbage out. They say 2 to 3 hours of just you speaking in a quiet room is enough. Time will tell. There is also, Microsoft did a whole bunch of work. I know that's an evil word here, but Microsoft released a paper about 2 months ago on being able to build apparently a perfectly good model with, I think it was 10 minutes of content or 5 minutes of content or something.
Don't believe that
Yeah, I find that one hard to believe. And then the other one was, I think Carnegie Mellon has recently done some work on it as well. A lot of work being done in the space. There's also Turtle TTS, which is an open source project on GitHub. Look it up. It is incredibly slow, but again, I can make that AWS's problem. That apparently does really, really well, but needs lots of content to get good.
For the record, Accidental Accessibility Advocate have actually done this myself. The standard is generally, if you record specific phrases, 14 to 16 hours worth of audio content will get you a model that is near perfect. 6 to 7 will get you a model that is good enough, and that's what's used for augmentative communication devices.
Yeah. And that's kind of about it, really.
My question is, since you created this whole process, what's the time duration after you give the transcript to the machine till it gets submitted to the YouTube?
So,
and just the second, just an add-on on this, is that you did not use your voice for this, right? Yeah. So it's very simple. Did you so what is the cost as well, which got is an add-on for this from the start till the finish in that one one request
for one video?
Yeah.
What's the end to end?
And is that like a minute video?
Yep.
Or
So
1 minute? Yeah.
So for the most part, a 10-minute video from the moment I make the API call to API gateway to the moment the video is sitting in the S3 bucket waiting to be submitted. For a 10-minute video is currently sitting at about 11 and a half minutes. Now, 8 minutes of that is the single Lambda function, the ffmpeg function, downloading all of the individual PNG files off the S3 bucket so that it can stitch them together. That's actually the bottleneck right now, because everything else is a throw more compute at it problem. I am currently looking at things like replacing the S3 bucket with an EFS endpoint or something like that so that I can do a higher throughput, because we can pump that into, but I've got to fix the FFmpeg bottleneck. So basically what I'm going to do is break it up so that at the moment when we draw the frames, each Lambda invocation does 10 frames. What I'm actually going to do is then have it spit out a 10-frame video so that I can then stitch 10 of those together and then just have an iterative approach so that it just, stitches it together so that, we're not doing one big stitch. Once I've done that, then I'll re-look at the storage problem to see how much of an issue it still is, and if it is, then the answer is, throw high throughput storage at it. As for the cost, as it currently stands, all of I haven't got an end-to-end for a single 10-minute video, but for the about 4 hours of content that I've produced throughout the whole development cycle, plus the videos that I generated for the Programmables content presentation and the Community Builder presentation and this presentation, has run me, I think it's $13. And I've probably generated between 4 and 5 hours worth of content at this point. So if you said, $3 an hour for content, you're probably in the ballpark somewhere. Play HT obviously comes with an additional expense. That's, as I said, about $200 a year, but that also gets me 6 million characters, which is about, they say, about 170 hours worth of content. So work backwards, it's like another $1 something an hour. So call it $5 and you'll have change.
Sorry, just.
Yep.
Okay. I was just wondering if you tried out 11 Labs, which is also another tool like Play HT, I suppose.
No, not that one specifically. I have tried a couple. The other one one of the big ones that I have tried is it Cynthia or something? It's the your humanoid robot where it's a speaking person, and again that was kind of the idea. The problem with most of those platforms I've found is they are horrendously expensive. Like I was talking to one the other day. If I wanted 18,000 minutes a year, it was going to cost me like $12,000 US. And I'm like, that's like US dollars a minute. And it's like, someone's making a lot of money here and it ain't me. Not saying that I want it to be me. Like if you got spare money, I'll take it. But yeah. It is kind of the thing. It's like, at what point do you just sort of turn around and go, yeah, dude, like cut out all that effort and just cut someone a check for $30 a month and be done with it. But again, I did it this way because, well, doing it this way is also content. So, and then I get to come and talk to you people and all that sort of stuff. Plus, it's just a fun thing to hack on, right? Because the next logical step is, okay, well, if you do a YouTube video, then, well, what about a blog post, companion article, and then the podcast, and you could build it out so like you could build a whole content network without having to lift a finger. The one thing is, for those of you who are sort of sitting here going, haha, jackpot, I'm going to build myself 1,000 YouTube channels and make $1 bajillion by just completely automating the end-to-end process, make sure you actually have a character in your video in order to justify the text-to-speech, because you will notice in the AdSense terms and conditions, programmatically generated content is against the rules. So they are really against the whole artificial computerized voice thing, unless you can justify that it's like one of the characters' voices. Hence, why there's a character in the video. Just saying. I hope Google never sees this.
Cool. Thanks, Matt. Close this down. We do quickly have marketplace segment. If anybody's hiring, please raise your hands. There's one there. Over there, the gentleman in the orange. Oh, sorry, a gray.
Hi everyone, my name is Gokul. I'm from SIBO. So we are hiring mid and senior data engineers, migration engineer, and DevOps engineer. If you're looking for opportunities, please do reach out to me. I can put in touch with the people and culture team so that you can have a chat with them. Thank you.
Was there anyone else?
Yep. Cool. Then I just want to again thank our sponsors, CMD Solutions, Versant, CIFO, and I finally remembered to put NAB on this slide. Thank you all. And thank you everybody for coming and presenting. Our next meetup is, as usual, the last Wednesday of the month. In this case, that will be the 31st of May. Right here, same time, same channel. Thank you all for coming, and have a good evening.